Hello and welcome back to ToMakeItGo. This is episode 22. In episode 21, we started building a die expression. So we got the base, got the bones of my semantic model built, and I was in the process of testing it. Looks like I was in the middle of mid-refactor when I quit last time. So let's make it. Let's finish that up. Um, what I just did is nowhere near Java convention for anything, but I needed a way of making integers. There we go. So assert valid that 1 plus 2, or an integer 1 plus the integer, or an integer 1 plus integer 2 is value 3 and 1.2. I could build my own custom hatcher, but I think this language will be sufficient. Let's build another method. Private number expression. D number of roles and number of sides, and we're just gonna always make this return. This will always return 2. 24. It should still be 3, but I'm just gonna run it because now it's gonna be the dicey dice notation. So plus 1d4, which I evaluated to 2. Let's switch those around inside. There we go. Add works how I would expect it to work. Yeah. Anything more, I'm just testing my subcomponents. Strictly speaking, this was probably enough. Let's go write this exact test for minus. Except this becomes minus. And that would be -1. This is 1 minus 2, which is also -1. And this is 2 minus 1, which is 1. Oh, yeah. There we go. And now that I look at that, I don't actually like. I like that better. Because then it's the expression. See, before. So let's go change that everywhere now. That's the problem with this sort of test, because I'm basically testing UI, and that means if I do nitpicky fiddly things like that, I have to go change it everywhere. That looks a bit goofy. Okay, so now there you go. I have some flimsy tests, but it's kind of flimsy because they're basically testing a user UI. There's not much I can do about that. So as long as I test constituent parts, and I don't make up my own expressions, I could always just use an integer and be like, yep, I'm testing it. That's probably actually better, so that this test is enough for a plus, and this is test for minus I. And then I don't have IntelliJ being like, you're writing stupid tests. Okay, and I'm not going to test integer, because that is nothing I should test. Okay. Now then, let us structure the thing. Oh, okay. So now, top class. I'm considering putting all in one file, the parsing and the lexing, because I build like very rudimentary objects. There's no reason to separate out my parser from my lexer. Oh, there we go. Let's see how this goes. We're just going to call this parser. Roll. What void parse? It's just gonna take a string. String. Input stream. Okay. I'm going to use a pushback input stream because I have to have a one look ahead. The reason for the one look ahead is because I have to have it because I can have it the way DIA is structured. So I have to be able to look ahead to see if the next number is another part of an integer or it's the symbol D, which is the signal to cut off. Okay. So here we go. Int current equals nothing. Do the standard monkeying about. Okay. We're just going to throw that IO exception just to this guy. So then, we have some states to worry about. Well, do we? We'll find out. Current. So if current let's first say is digit. Which I actually think exists. Aha! So if the digit, else if is D. So this is current equals D. Current equals big D. Else if is plus. Else if is minus. And I'm just going to treat all other characters as garbage. Because, no, going. There you go. Bad character. I could have an else if is white space, consume it, and then else throw an exception, be like, well, I don't know what this is, and give them a line number or what's the one I'm looking for? An error message with line number and over, so line number and character number, column count, column, line and column. So line 4, column 3. That's where I'd handle that. So is D. So now then, we will do something crazy. We will build a string current digit. Okay, we also need to have some states. So what states do I have? I have actually, I'm going to try something crazy. No, I won't. Okay, here we go. Okay. So then, varying along the stream, so if we're an integer, we need to collect all the integer tokens and the current digit. No, there's no reason to do that. Just cast it to a jar. We know it's a jar. Let's go jar. I'm going to wrap that just for paranoia's sake. Okay. I'll go building a thing. So now, this will construct a plus operator. He did the thing. Okay. Okay. Current expression. I'm sorry for going real quiet. Okay, I need to talk about what do I need to talk about? So, a number expression. Yeah, number expression. Current. Let's just call it DXP. Expression. So we're building up our expression as we go. We hit this. We need to check. So it's D. So we're going along with building up things. Collecting things. Okay. So for collecting stuff, and we hit that digit. At this point, we need to current digit or integer.parse. Because I know that at this point, my last thing is a current digit. And I need to make a new D integer from that. I need to set it to nothing. Because I've collected it. I need to mark that I am in the state of a number. Or no, that I am in a digit. Or a die roll. So this means a transition to the die roll state. So let's go make a private enum. States. So we are in number. Our integer. We are in integer. We are in die. We are in plus. We are in minus. And I actually don't know that I need to do that. Yeah, I do. Okay. Now, no matter what, we start an integer. States. State equals states.integer. We always start an integer. At this point, we would transition to state.states die. So I'm in a die at this point. Okay. Let's go. We also need to ask. Now then, what do I do with my integer? I have to store that. We'll put that up here. At the moment, this is going to get real messy. The integer. Actually, so the only thing valid to do an integer is to keep creating that current digit. So I'm in the integer state, create the current digit. If I am a D, I set a state D integer last integer equals this guy. Stay in my state. If it's plus, I do this same thing. I don't care what's there, I just shove it in there because my other integer would have handled it. Some of the die state, I don't. Yeah. Same with minus. So minus current is plus. Except I go to different states. As you watch me stumble through a state machine. So this goes to plus. This goes to minus. Okay. So if I'm in a die, I would grab the same chunk of this plus is minus. Else I don't do anything. Okay. Grab this whole chunk. So if it is D, that one I throw a fit because I don't do that. So if I'm in the D stage, because this guy will have already consumed my D token. Can we throw it away? We'll throw it away. Okay, there we go. Okay, so after D we do nothing. Here we go. So if we hit a plus sign, it means I need to do this. No, it means I need to create a new die, ast integer. New D integer from string dot parse or integer dot value of current and expression equals that. So and it wants me to make that null. At the moment, you can watch as I make the most awful code possible, which may tell me that this is just a bad idea and I should stop. My last integer. Yep, bad idea. Stopping. So you've watched me fiddle around and decide I don't know what I'm doing. So I need to go back and think this through because all of this is just bad, just awful, just awful. Except this. This is good. I quite like this. Okay. So you've watched me fool around for a bit, and I've come to no conclusions that everything I'm doing is wrong. Okay. So let's step back and do some simplest thing I can. The simplest thing I can do is make integers. Not everything in that was bad. I still have to have that while loop. and that initial structure. Yeah, everything else is garbage. Okay. So then, if it's a digit, we keep building them up until we encounter something that's not. Okay. Let's okay, so let's build a token. This is probably a public static class. Token. So this is going to be a string value. And enum type. Okay. Now then, at this point, that I need a string integer. It's going to equal nothing. Okay. So then, integer plus equals. Make it a char of the current. If integer that is empty. That is empty. Alright, build up a list of tokens. Linked list of tokens. So at this point, if it's not empty, tokens.add. This is going to be new token. At this point, we grab it. The type is string. So we know that it is a integer. And the type is integer. Token.type is integer. Token.type. Okay. Then integer gets cleared out. And that's it. And then I put that also tokens.add new token d lowercase d. Okay. So that should Lexer. Then we return tokens. Okay, built up my lexical tokens. And then this gets to be minus. This gets to be plus. This is a plus. This is a minus. Other way around. Plus, plus, minus, minus. There we go. Let's clear it. Add the token. And last but not least, I need to check to see that that's empty. There we go. Look, a nice little class all wrapped up in a method. I've made an awful decision. Okay, so next we test to make sure that this works the way I think it should. There you go. Before I leave, I'm going to put getters on this. And equals and hash code. There we go. That'll help. That'll be useful for testing this sucker. Likes. So then, I'll wrap a test around that to make sure that does what I expect it to do, and then I will have something I can operate on that is a bit higher level that tells me what to do. Because then I should be able to perform operations on that list. So then I will have a better system to work off of. Okay, so this has been episode 23 of To Make It Go. Thank you for watching. And I'm going to double check on that. Yep, episode 23. Well, 22. Thank you for watching. Have a nice